In this video we're gonna study about the driver monitoring system. So in today's driver monitoring systems we have cameras, infrared cameras mounted on the steering wheel, and it performs the analytics and AI information collection of the data. It monitors the head pose, the blinking of the eye, and based upon that it gives the ratings. If you see the unresponsive driver, on a distracted driver with the phone, sleep, micro sleep, long distraction, short distractions, and based upon that alertness, it generates the triggers like display pop-ups or steering wheel vibrations. So in this video we're gonna study this and how to implement this. So if you see in modern luxury vehicles, we have like brands like Mercedes, BMW, and Tesla have a DMS incorporated into their high-end models. In autonomous driving, it is very crucial for semi-autonomous and autonomous driving. It really monitors the engagement of the driver and how ready it is to take over the control. It is also used in fleet management in commercial vehicles to monitor the performance of the driver alertness to improve the safety and reduce the incidents. So if the what if the drowsiness is detected? What happens? If the drowsiness is detected, first there is audio visual alertness display, vibration in the steering in some models. In Tesla, if the driver is not paying attention for at the autopilot for some duration, it will lose the privilege for a few hours for the safety. And in some vehicles of the Volkswagen latest, it's also park the car in the side of the road. In some vehicles it will come like it will also call the emergency if it detects the driver unresponsive. So now let's understand how this thing works together. So it works with camera based monitoring, and the camera is taking the pictures at like 30 frames per second. If the infrared camera is used because the interior of the car is dark, so that infrared camera is used. It also tracks the eye tracking, head pose tracking, facial recognition, and landmark detection. So in this video we will study about the OpenCV and Dlib and use the eye blinking. So now let's understand what other parameters are used to monitor it. The behavior analysis is also done, alertness detection is also done, driver state classification is done. So what's a behavior analysis? So behavior analysis is like monitoring the hand movements and the body postures, like person is using the phone or reaching to the object or excessive movement is detected, a behavior like violence or anything detected in the vehicle. Alertness is like how the alertness is detected. Alertness is like if like it detects the prolonged eye closure like head nodding, system triggers and alerts, audio visual, vibration of steering. So now what about the driver state classification? The system continuously accesses the driver state and classify the attentive, distracted, and drowsy or unsafe based on the data inputs. All those information coming from the cameras is like analyzed. This is feed to the AI, which has the convolutional neural networks or the RNN, and it processes this visual and sensory data in real time. And once we have this DMS information, it's integrated with autonomous driving and the ADAS systems, where it takes the corrective actions like alerting, adjusting the speed, lane, or changing the lane from one lane to the lane and going towards the stopping of the car. So I have uploaded a video in which I in the same channel in which I am closing my eye, and the closing of eye is makes this graph go down, and based upon the consecutive frames like more than 3 frames it detects as a sleepiness. So what exactly it is happening is like DLEV is used to I am using a webcam, a USB webcam, to monitor myself, and there is an eye aspect ratio. If the eye aspect ratio fall below 0.25 threshold, it goes into the zero state. The blinking of eye detects. If more detects more than 3 consecutive frames, it considered as a sleep. Now, what libraries were used for this project? I used the CV2 computer vision OpenCV, which is a very common, Dlib, time, NumPy as an NP for the numerical arrays. Dlib I have used for the face recognition and facial landmark recognition. MATLAB I have used MATLAB lib or matplot for the plotting of the data. For the eye aspect ratio and Euclidean distance, I have used this function, and I have used the logging function to log the data. So I will explain in detail in these slides. So Dlib OpenCV is used for the computer vision task. Is a highly optimized library designed for the computer vision application. It provides tools for the image and video processing, object detection, facial recognition, and others, like video capture and processing. So in the real time, I'm capturing the webcam image using this function. And in this project, it is also used to detect face, eyes, and other landmarks. So what is Dlib? So Dlib is the machine learning toolkit. Is modern C++ machine learning algorithm is already implemented, and the complex software. It helps to detect the face and also the landmarks on the face. It offers the pre-trained models for the face detection and landmarks detection, which is crucial for identifying the features like feature extractions like an eyes and nose and mouth. What we are using along with Dlib is the time module, because we have to calculate the time eclipse, like how many consecutive frames this eye was closed to consider it as sleep. So we are using time function. You can get more detail into it. We have used the function library called numpy as np. So what numpy is used for? It is used for large multi-dimensional arrays and matrices, along with the collection of mathematical function to operate on this array. So once we have the pixel data, we want to convert into the array for data manipulation. It's essential for handling the image data. So that's what I'm trying to explain, which is typically represented numpy array in the OpenCV. Now, fifth library I used is matplot module and use the module pyplot. So now what I'm doing with the matplot is we are plotting the eyes blink state. So create a static, animated, and interactive visualization in Python. So it has a real-time plotting function. In this project, we have used to plot an eye aspect ratio over the time to monitor the driver state. So if it go below some threshold, we are considering as sleep, so we have to monitor the graph. Now this is very important function called sci py module and this dot sci py spatial import distance. You can read more detail about it. Now the purpose of this, like we have to calculate the distance between the horizontal and the vertical distance of the eye. So what we are doing is like provide the function to compute the distance between the points, like Euclidean distance. So once we have extracted the features like an eye from the face, we want to calculate the distance between the vertical and horizontal path of the eye. So this will help us to determine is the eye is blinking or is eye is open. And this is another function we have used for monitoring the data points such as EAR. EAR is the eye aspect ratio, which is useful for real-time monitoring and plotting. Another function we have used import logging. So this is being used to log the images, the messages, and like debug, info, warning, and error critical to the categorize. Now let's understand how this library is in import gonna help us. So like I said that we have used the CV2 OpenCV to capture the live frame by frame information of the webcam. Now how we detect the frame? We detect the face by using Dlib, which is detecting the face in each frame. Now there is a function library called like facial landmarks in the Dlib, which will determine these are the landmarks of the face of detected face. So if you see the eye, we are interested in this region, so we will go in depth of these points and calculate the distance. So now numerical operator numpy is handle the image data as an array for efficient processing. So all the information is in pixel and this is converted into the arrays using this function. Now in order to calculate drowsiness detection logic, we are using this function distance and collection dengue. So there's an eye aspect ratio calculation. So what we'll do is that this function calculates the distance between the eye landmark to compute the eye aspect ratio. We will see in the depth in detail of this video how it has been calculated. Now to consider sleep or not sleep, we have to track the history. So this function helps us to maintain a sliding window of recent EAR values to determine the trends indicating of drowsiness. Now let's understand why we use this function called matplot, this function and the CV2. So we are processing the images from the webcam using the CV2 and we want to plot the data. So we will use the matplot function, which will visualize the EAR trends aiding in monitoring diverse state. So what we are saying that state 0 is sleeping and state 1 is non-sleeping. So this is non-sleeping. When I close the eye, it goes down. So and relative to the time, we are plotting the graph. So this is the coming from matplot and the time function, which is this one. Now logging and debugging, we want to log each event. Obviously this is a complex algorithm and we want to determine the detection error state. We are using this function. We will go in depth in this video. Now this is the line of the code. Configure logging.basic config file name. If you see this one, so I have put a detail on this slide. You can pause it and read it about. Basically this is only doing the logging function and how the logging is implemented. Now let's understand how we detect the face, and after we detect the face, how we detect the landmark. So basically if you see this one, to set up a Dlib tool for detecting face and identify landmark which are crucial for analyzing such as eye movement, we use the component called predictor underscore path, and we give predictor underscore path a file. This file is a hog transform file, and we give this file in the same folder of the project, and then we will run this detector is equal to dlib.get frontal face detector, and after you detect the face, predictor with the so dlib.shape underscore predictor. So what exactly is this thing does is like it detect the face, and then we are saying that predict the landmarks. If you see in detail, so this function detector initialize the built-in face detector, which is a hog based detector. Now what this predictor does, it loads the facial landmark predictor using the specific .dat file. So what exactly is this thing is doing is it will detect the landmarks on the face of each frame, and these functions like logging.info and logging.error is like whatever happens. So in this case, if it successfully initializes the delay, it will log this message, and this one will log as an error if it doesn't initialize the Dlib. Now let's understand. Okay, we have points now. Now we want to calculate the eye aspect ratio. So what is eye aspect ratio, first of all, and why it's very important? If you want to consider a person is sleeping, then it will have a lower eye aspect ratio. This means that horizontal distance and the vertical distance ratio will be low. If you see this thing, when the eyes are open, then the EAR value is high. Remember this thing. The distance from here to here and distance from here to here will be higher, the ratio of it. So that's what this function is doing. It's very simple. A plus B divided by 2 into C. What is A and what is B? A is the distance, Euclidean distance of I1 and 5, which is I1 and 5. What is B? Euclidean distance of I2 and 4. Okay, 2 and 4. What is C? Euclidean distance between the I0 and ith array third element. See this. Okay. Now why what this function will do is, like, this function, upper part of this function will calculate the vertical distance, which is this one, and the lower part C will calculate the horizontal distance, which is this horizontal distance. Remember, eyes closed will have less EAR value. Okay, you can read more detail in these lines what A corresponds to. You see, corresponds to Euclidean distance of the second and sixth point of the eye landmark. So what is the second and sixth landmark? It is this one of the landmark. Okay, and what is the Euclidean distance third and fifth of the landmark? Third and the fifth is this one. What is C? The Euclidean distance between the first and the fourth of the landmark. First and the fourth is this one. Okay, so now if the eye is open, it will have high EAR value. If eye is closed, it will have low EAR value. Now we will give a threshold value of 0.25 and consecutive frames 3. So if the eye's AR threshold is 0.25, below it is sleeping, and its consecutive 3 frame is considered as sleep. Now we will have a function called for frame counter. We are counting the frames and total number of blinks. We are also calculating the blinks. So more you blink, then this counter will increase. So these are the functions to initialize the plot. You can go in detail to this one. Now, as I say, this is the constants we are starting initializing. You can read more in detail if you're interested by pausing the slide. Now what this function does is, like, it captures the video from the webcam. If it's not open, it will give an error. Now what is this function is doing? This function is converting the captured read frame by frame. If it fails to read the frame, it will give an error. After we get the frame, which is this one, we convert the frame into the grayscale. Why grayscale? The grayscale is more often in computer vision and reduce the task or computational complexity. Now after we get the frame, we have to detect the face into the frames. This function does that. So now we are initializing as a non-sleeping state. Now we will loop through the detected faces. So this function loop through the detected faces. Now predict the facial landmarks. So we predict the facial landmarks using this function, and you can go in depth of this one by reading this values and details. Now what this function is doing, like numpy.array, it extracts the xy coordinate of each landmark. So in the live video or a live frame, which pixel is corresponding, it this is what it is converting into. Now extract the eye coordinate. So now we want to extract the eye coordinate. Remember, left eye is 36 to 42. 36 to 42. Remember, this thing has one value extra because array starts from 0. So left is this is the right value from shape 42th array value to 48th array value, which is 43 to 47. Okay, so understand this thing. So what this function will do, extract the coordinate of left and eye using the specific eye. So and now we want to draw a region, draw the eye region. So around that eye region in each frame we enable the blue color. Okay, this function does that. Now this is very important. We want to calculate the EAR for both the eyes. So for the left eye aspect ratio left eye, right eye aspect ratio right eye. Now EAR value is left eye plus right eye star 2. What this function does, now this function calls for previously defined eye aspect ratio function to compute EAR for the both left eye and right eyes. The purpose is that EAR is a key matrix used to determine whether driver is drowsy based upon how open and closed is. Remember, the function calculates the average value of EAR of both eyes. So now this one logs the current value of EAR for the logging purpose, this line of code. Now update the counter based upon EAR. Now this is very important. So if the value of EAR is less than I threshold, which is 0.25, the counter is incremented. Else, if EAR is greater than consecutive frames, which is 3, total is incremented. The total is the number of blinks and the counter is like how much time is sleeping. So now let's understand this thing. So if EAR is less than AR threshold, which is 0.25, indicating that eyes are likely closed. If true, the increment the counter, indicating the potential state of drowsiness. There are chances that a person is drowsy, but we will need more than 3 frames. If it's we will increase the counter one by one, and helps if it's increased till more than 3, we will consider as a sleep. So now state is equal to sleeping if the counter value is greater than equals to AR consecutive frame, else not sleeping. And this is the logging. And what these values are doing, display the year and state of the frame. So this value in each frame, we are whatever the value of EAR is, we are printing on the screen. So if you see this video, this thing is coming from that line of code. Okay, now these lines are used to update the plot, and you can see in depth, and this is the end of the lines used to plot the data, show into the frame. This is the small window to see the frame. I can show you the video. It is in the other video of this channel, practically how I am doing it. I can give the code too, but if you need the code, just comment below. Thank you.